Good morning. This is our MSc final year organic chemistry class, and in this we are studying name reactions. And in name reaction series, last time we studied Baeyer Villiger rearrangement, or which is also called Baeyer Villiger oxidation. So today we will continue with that, some more examples of Baeyer Villiger oxidation. But before taking some more examples, let me just brief you what happens in this, what we studied so far. That in these reactions, ketones, by the use of peracids, are converted into ester. That is, you have to introduce one oxygen between carbonyl group and the alkyl group, and that oxygen comes from peracid. That oxygen is coming from peracid. Key point was, after studying the mechanism, you come to know that migratory aptitude is important in case of unsymmetrical ketones. Now, in case of unsymmetrical ketones, what will happen? The group that migrate, the oxygen will be introduced between carbonyl group and that group which migrates. That is the shortcut for writing the final product of any of the ketone into esters. And second important thing was that this oxygen, carbonyl oxygen, remains as such. This is as such. Evidence for this was given by taking isotopic oxygen. And today we will take some more examples related to this. Okay, I hope this mechanism is clear to you. Only then we can understand the next example which we are taking into this. Okay, let us take some more examples related to Baeyer Villiger oxidation. Today, let us take, say we have diketones. And diketones in this case are converted into anhydrides. Diketones will be converted into anhydride. For example, say you have this diketone. This you can say is an application of Baeyer Villiger oxidation. Diketones, we have here 1,2 diketones, and 1,2 diketones on treatment with, say, trifluoroacetic acid. Oxygen in this case will be introduced at this position, and this oxygen is coming from this peracid, and as a result of this, product formed will be this acetic anhydride is the product formed in this case. Now similarly, if you are taking, say, orthoquinones, for example, like this. See, we have orthoquinones. Again, they are diketones. Same, say we are taking trifluoroacetic acid, peracid, trifluoroperacid as the oxidizing agent. Then what will happen in this example? Again, oxygen will be introduced over here. Oxygen is introduced, and what we get is cyclic anhydride. You will get cyclic anhydride is again formed. Now to write down this product, see how to write down the product. Keep this ring as such. This ring is kept as such. Then we have this. Then we have this. Then we have this. This is this. Okay. This oxygen is as such. This double bond is, let's convert this into double bond O. And you are getting a oxygen between this and this. So it's this type of cyclic anhydride is formed from this type of compound. This is again an application of Baeyer Villiger oxidation. Now let me take some more typical examples for this. Baeyer Villiger oxidation. Say you have a compound like this. Let me draw this bicyclic compound like this. This is ketone, this is the example, this is this, this is this, and see we have one methyl group also over here. Now what do you think? Now in such case, say we are taking any peracid, Generally, we are any per acid we can take for the oxidation. No, no, product will be ester. Now there are two possibilities in this case. One is that oxygen is introduced between this and this, and another possibility is that oxygen is introduced between this and this. And let me draw both these products first. This and this. If one is this product and another expected product will be this. This is our oxygen which was already there, double bond O, and this comes in between this, and this group is as such. Now say this is compound 1 and 2, both are the product possibilities are there. But in this case, if both the options are given to you and which asked which will be the major product in this case, major product. So major product in this case will be this. Although migratory aptitude expected to be of this more because of this methyl group, but steric hindrance will play a role over here. So due to steric factor, this product is going to be the major product. I hope this point is clear. Due to the steric effect of this, introduction of this group over here and here will be difficult, and some strain will also be there, and hence this is going to be the major product in this, although both are formed in this case. Okay, I hope this example is clear to you. Let us take some more example. Say we have an example like this. Again, see, again there are two possibilities, this and this. In this case, steric hindrance is not that much, so if written like this, we can say both the products are possible, and our products can be written like this. What I have done is this. Okay, I am removing this. No, it will be like this. See, this double bond is O as such, and this is not there. It will be like this. This is the product formed, and second possibility will be that this. Let me see the reactant first. Written like this, and then this. Here you have double bond O, and next will be introduced between this and this machine. This will be these are the two products formed in this case. That is this example. Now one more typical point you can note about this, which is very useful, which can be very useful to in competitive exams, and you can note down this point very importantly. If chiral carbon is present, if carbon is chiral, you can say if chiral carbon is present, then after the reaction, stereochemistry remains intact. Stereochemistry does not change. This is a very, very important point, and we may get confused like this. Let me tell you, one question was asked in net and options. I will show you what can be the question. This, say, this is given to you 2,3-dimethyl cyclohexane. 2,3-dimethyl cyclohexane. This is given because both the groups are on side. This is a cis, and see we are doing its oxidation with metachloroperbenzoic acid. Now see, option, we know this is the tertiary one, migratory group will be better, and oxygen will come between this and this. The product is very easy to write. Product is again I have written this. Chalo. This line is not there actually. This is double bond O, and hurry this, and we will get an oxygen in between this and this. This is not there. We'll get oxygen between this, and this is the cyclic anhydride form. But important point here is that this methyl group, their position will remain as such. And when this type of question was asked, in one option they will say this, in another position this, in says both up, both down, and they will change this stereochemistry. But important point is stereochemically this remains intact, and hence answer is this. This can be confusion when asked in this question, hence it is a very good examples for this. Okay, next let me take some more example for this. See, we have aromatic aldehydes, है ना. So aromatic aldehydes are converted into formates, say like this. We have example like this, and we are doing it with per acid. Say we have taken any R, per acids. In this case, aryl group migratory aptitude you have studied is more. In this case, oxygen is in between this and this, and after ingestion of oxygen, our product will be like this. C double bond O H. What is this? Ester, but formates are formed in this case. And if aromatic aldehydes are like this, then we can get aldehydes are converted into acids. Aldehydes are also converted into acid if it is like this. For example, see, it is like this. We have aldehyde, we have a group over here, we have some electron releasing group over here. Now why so? See, why it is a peculiar example. In this case, now migratory aptitude of hydrogen will be more here, and migratory aptitude of hydrogen being more, product formed will be, oxygen will be introduced here, and hence answer to this will be this group as such, this group as such, methyl, this is methoxy, and then here, okay, it is here, you will get C double bond O OH. That is this. That is, aldehydes can be converted. If it is like this, they will be converted into ester. But if it is like this, because this is electron releasing group, and this is methyl group, this bulky group, so in this case, migratory aptitude of hydrogen will be more, and as a result, product formed will be a carboxylic acid. Carboxylic acid is the product formed. Carboxylic acid will be the product formed in this case. Okay, तो let me give you one example for you. आप एक example solve करें और उसका answer मुझे बताएं. Say this is an homework for you can say. की point क्या होगा मैं बता दूंगा इसका, लेकिन थोड़ा hint, लेकिन आपके लिए homework होगा ये. And see, we have a tertiary butyl group over here. Tertiary butyl group over here, and you are doing this reaction. इस reaction को आप कर रहे हैं, तो what is going to be the product in this case? इस केस में हमारे पास क्या प्रोडक्ट हो जाएगा. तो आपको क्या ध्यान रखना है यहाँ पर, जो मैंने पहले जहाँ से स्टार्ट किया था बताया था एग्जाम्पल. तो दिस इज जस्ट ए होमवर्क फॉर यू. यू विल बी टेलिंग द आंसर. हिंट फॉर दिस इज two products are possible. One is this and another is this, introduced between this and this carbon, but that is will be the major product. तो आंसर तो हो गया एक प्रकार. आपको लिखना है केवल इसका आंसर, बिकॉज here steric factor will play its important role. Steric, due to the steric factor of this group, oxygen can be introduced over here, but that will be very less. Most important part, major product will be this one, when oxygen is introduced with this and this carbon. Although migratory aptitude of this is expected to be more, but due to steric hindrance, product will be this. Okay, so this was about Baeyer Villiger oxidation, and we'll continue in the name reaction series with some more reactions. Keep doing your work. Thank you very much.